Hi class, welcome back. We are now into week 6 of our course, so we're past the halfway point. We're in lesson 6.1, and this week is still on biomimetic design process, but now we're focusing on discover phase. So going back to the challenge to biology design spiral, we've covered identify and interpret or translate, and now we're into discover. And I'll point this out again in a minute, but as you get better and better at this, and as you're finding already, one step leads to the next, sets you up for the next, sets you up for the next, so you end up doing them a little bit seamlessly. It is important, though, to look at them as separate steps, especially at the beginning, because especially those of you who are very design-oriented or solution-oriented, the tendency is to go right from identify to discover, and that is, or right from identify to discover to emulate. Okay, so we end up jumping right into the solution space, and that's not leveraging the full power of biomimetic design. So when you're in the discover phase, just enjoy being in the discover phase. Okay, so here's where it fits again. We've got identify, translate or interpret, and then we've got discover. And this is when you get to spend time in nature. So again, I hope you get to enjoy that. So in the discover phase is when you're discovering a natural model, or seeking many natural models and strategies to do the functions that you've identified and you've translated in the previous 2 steps. So the discover phase is fantastic because it gives you an excuse as a designer to go outside. And when you're in the discover phase, you want to consider both literal and metaphorical models. One of the challenges of the term biomimicry or biomimetics, it's got that mimic word in there, right? Mimic usually means to actually directly copy, sort of to ape something. So nature's doing it this way, I've got to do it that way. You can do it that way, right? But it's more about being inspired by how nature is doing something and perhaps doing it better, combining it with other things, or just taking a metaphorical approach to it. So you see the general approach that nature is taking, you go, okay, that's a fantastic approach, and I'm going to emulate that. Okay, so when you're in the discover phase, consider both very literal and metaphorical models. In the discover phase, it's fantastic to go outside, reconnect with nature. That also helps you remember why we're doing what we're doing, as far as reconnecting with nature. But you want to comb the literature. If you're not a biologist, you can certainly read popular literature and other popular media sources, and then give a go at reading some more scientific literature. They're often structured so the front end of it is a little bit more accessible to non-scientists, and then you can dive in deeper. Another great thing to do is to brainstorm with biologists. We've talked about this before, but this is a great phase in the discover phase to talk to biologists and start discovering with them. And as always, you can go to Ask Nature. One of the reasons that biomimetic design and the discover phase in particular is so important, especially for sustainable design, which, as you recall, is really about radical innovation, is that it helps you shed any preconceived ideas that you didn't even know you had and bust open your solution space. You already started to get that in your identify stage, right? But let's just give it a little example, okay? So let's say that you're given a design challenge, and your challenge is to imagine an innovative, sustainable personal vehicle. All right, and I don't want you to pull out any pens or paper for this one. Just use your imagination, which of course where all design starts, right? So right now I want you to close your eyes for about a minute and imagine an innovative, sustainable personal vehicle. And I'll just wait here for a minute and tell you when to open your eyes. Okay, open your eyes. No, that wasn't a minute, that was a half a minute, but I couldn't wait any longer. But the point is, I'm hoping you have some kind of innovative, sustainable personal vehicle in mind, all right? Now, how many of you came up with something along the lines of this? Or maybe this? Something like this, perhaps? Did you maybe envision something like this? Or maybe more along the lines of a flying personal vehicle. Something like this, or this. Or maybe you were thinking back to the old version of futuristic vehicles. Or something cute like that. Maybe some of you were imagining a bicycle-based sustainable personal vehicle. Like this, or perhaps like that. Then there's the ones that are like segways, perhaps like this, or like that. Did any of you, did that cover the spectrum of what you were thinking of? If you thought of something wildly different than any of these sorts of things, good for you. Because when most of us think of a new innovation, what pops into our minds automatically and what are into our imaginations is really incremental innovation. It's basically a modification that's something on something that already exists. And we talked about that a bit before. So when I said the word vehicle, it's really hard not to suddenly in your head come up with a car, a helicopter, airplane, bicycle, Segway, something along those lines. In other words, a modification of something that already exists, okay? And really what we're looking for is radical innovation, right? So if you want, most of what we're doing now is not sustainable, even if you made a whole bunch of improvements on it. So radical innovation is doing something or creating something entirely new or an entirely new way. And it's a lot harder than incremental innovation because of the way our brains make these automatic associations. So now let's imagine an innovative, sustainable personal vehicle, but this time, what if we thought about the functions this vehicle was to perform? And then we thought about how does nature perform these functions? If we did that exercise again, I'm wondering if maybe you might think of something like this. Or perhaps something that works like that. Or perhaps something like this. Or maybe this. Maybe something that hops, leverages water tension, maybe hitches a ride on something else. Or in something else. Maybe it takes advantage of the wind and just tumbles along. Or maybe it's a cute suit you get to wear. So we've got all kinds of different ways to transport in and out of water, in the air, floating, carrying precious cargo, having special adaptations. And then here's our little buddy from today. So if you were asked the same design challenge again using a biomimetic design approach, and you went into the discover phase, suddenly an entirely radically different way of approaching personal transport would come into play, okay? So that's the power of biomimetics, and that's what I want you to play with this week. Just be in the discover phase. Don't worry about solutions. Enjoy all the different things that nature can teach you. Now, we've been talking about functions earlier, and now we're talking about strategies. So again, strategies are the ways that nature accomplishes these functions. And one of the important things about strategies, they're outside of life's principles. So life's principles are true all the time for every organism. Some of them are much more obvious than others, some are much more important to a particular organism than others, but all living things follow life's principles. Now, each organism and each system has its own strategies for accomplishing these principles, okay? So we were talking about how transport, and so each of these organisms has different ways, different strategies of accomplishing that function. So when we're talking about strategies, things you want to look for are materials. It might be the structure of a material, what it's made of, how long it lasts. It could be what it's made of. You might want to be looking for form. We talk about shape and geometry. So how nature leverages information, it leverages shape instead of just adding more material, right? Okay, so you look for materials, forms, shape, geometry. You can also look for processes or chemistry. That could be the strategy used to accomplish the function. And you can also look for synergies or systems approaches. And we talked earlier about how often organisms don't even have an internal strategy for accomplishing an important function. They have the system or some synergy with another organism that manages to accomplish that function. Also, to consider when you're looking at strategies is scale. So nature often works at this micro scale, something you can't see. So at the nanoscale, and in every scale up to landscape scale. So sometimes, again, things happen at the landscape scale in the ecosystem, right? So think about different scales. Think about dynamics. We make things, we tend to like get the job done, right? And the thing is designed and it's built, and that's what it is. Nature is always changing and growing and changing as it grows. So there's dynamics. Things are accomplished differently over different times in scale and also in place. Think about combinations. Nature often puts different combinations of things together to perform a certain function. Like one example is nature might use a combination of chemistry and morphology. In other words, some kind of process and shape put together, and that's what it uses to accomplish that function. Okay, so don't limit yourself to thinking about just one particular, say, material or shape. Okay, so think about these combinations you might see. And then start looking at patterns. The more you look at models in nature, more and more organisms, certain patterns will start to emerge. So if, for example, you're looking at how does nature create color? Well, geez, there's all these organisms out there that are colorful, right? So they have all these different strategies. But you start to see patterns emerge. Okay, this set of them uses some sort of structural approach to creating color. These others use a pigment. Okay, so you'll start to see these patterns emerging, and each one might do it slightly differently, but you start to get the idea, and that's very helpful, especially when you get to the abstract stage. Notice that often one strategy performs multiple functions, okay? And if you look at our little friend here, these eyes, they've got there's geometry, there's chemistry, there's material, you can see structural color, and of course those are all performing different functions along with the function of sight. So it might have one strategy, say the geometry, which is performing multiple functions, and you've seen that in life's principles. Also, one function might be performed by multiple strategies, which is getting back into this combination. So in order to have sight, this little bug here might be combining material and geometry and in the structural color, okay? So keep that in mind. Some things to notice when you're trying to find strategies, look for extremes. So if you're trying to find how does nature keep warm, for example, or how does nature regulate temperature or maintain temperature, something like that, you can look at the very extremes, the very hottest, very coldest, the very wettest, driest kind of extremes to see how is it done there. You can also look for opposites. So if you're trying to say, well, how does nature move? You could say, how does nature keep from moving? Or how does nature keep dry? How does it keep wet or keep from getting wet? So you play around. We talked earlier about reframing the question, and this is one of those ways of doing that. Another thing to notice is when that function appears to be missing, or when you discover a strategy in one organism and it's not there in another organism, and yet that function's being performed. It's like, gosh, well, how is that function being performed? And I had a big aha moment because when I was in Costa Rica, my husband's a soil scientist, and the soils in the rainforest are really crap. They flush through so quickly. They don't things degrade really quickly, so it's not a big, thick, rich soils layer there. And in fact, a lot of plants go right out of like little notches in trees, these epiphytes. Like, how the heck can a plant grow without soil? And then I noticed, what was missing was the soil. So all the functions that soil performs has to be performed somewhere. It's like, wow, there's some really neat strategies for accomplishing the functions that soil provides up in that little notch in the tree. So that's another thing. Notice what might be missing, either the strategy or the function. Chimera means you can, as a designer, we don't have to adhere to the way nature does things. Again, we don't need to mimic. We can take an eyeball strategy from the fly and combine it with a foot strategy from the frog, okay? So you are, as a designer, as humans, we have the ability to do that. Some tips, and I mentioned this already, stay out of the solution space when you're in the discover phase. It is so compelling when you're inspired and seeing these cool strategies to go right off and design something. Resist that temptation, or at least if you go do it, go right back into the design, into the discover phase. So you don't get too wed to a solution too soon. That just really shrinks down your solution space. And just allow yourself to run free and discover for a while. Allow for metaphors. We mentioned that at the beginning. So don't, again, get hung up on actually mimicking the physicality of what you see. You get the idea of, oh, I see. You can use this type of approach, but you don't have to mimic it exactly. And I guess I just said that there. We don't need to mimic. We've talked about this earlier too. Humans are part of nature, right? We did that breathing exercise. You are natural. So humans come up with all these great solutions. Some of them are not so great from an environmental standpoint. But you can be inspired by human solutions to something and then go back and see, well, how do other organisms other than humans do that? Okay, so you can include humans in your discover phase. Go very, very broad. So think really broadly. Think across all the different kingdoms and ecosystems around the world when you're seeking strategies. And also go very deep. If you pick up one guy, like one bug, one plant, and think about all the different things it does, all the different strategies it has, all the different functions it performs, and different things are revealed when you go through those different processes. And we talked last week about the power of spiraling. I just can't say enough about how great the spiral process is. Another great thing about it is it doesn't matter what organism you start with. So if you've got a function, you can start anywhere. You don't have to start with anything that's appropriate or the best or anything. You can start with whatever's in your backyard. That's why we talked about discovering your own backyard. You could, fly that might be buzzing around, a picture of a frog you see, something you find outside, something you see in an aquarium or in a book. It doesn't matter because all of them follow life's principles, right? And all of them perform those basic functions of life we talked about a couple weeks ago. So start someplace, discover some strategies and go, okay, well, who else does that? And move on and move on and move on, okay? So enjoy the power of spiraling. Okay, so after this little not so short video, you're going to read this, Biomimetics, 10 Questions and Assumptions by Nikolay Bogotyrev. I can never say his name properly. Nikolay is all about biotriz. So if you want to it's another form of biomimetic design that he and his colleagues came up with. They're very, they think it's the solution to everything. It's, you can look them up more, but he's pretty critical of biomimicry per se, so you'll get an interesting perspective from him. This is Julian Vincent. He also is very cynical or critical of biomimicry and is very much about biomimetics and structural biomaterials. So you'll get a perspective from him. This is kind of heavy reading, but it's good so you can see from his standpoint, a combination of a biologist and engineer, something that, how he discovers, okay? And then you get to do a BCI session, and this time you're going to be really focusing on looking for strategies for your portfolio project. And then in lesson 6.2, there's no more videos after this, you're going to use Ask Nature for your discover phase, and if you want to go back through these websites and tutorials again with the eye for discover phase this time, please do so. And you're going to write a little project update report. And you're going to be doing that for a lot of your assignments from now on. And these will help build towards your final portfolio project. And then you're going to do a discover phase again, this time not using Ask Nature. I want you to use any other sources you can think of, whether it's these big nature books, National Geographic, or other kind of journals. Of course, you can just use the web. You can watch videos. You can go to a local botanical garden, arboretum, local zoo. Go back to your natural spot, this time with your eyes open without contemplating, perhaps, your own garden or your neighbor's vegetable garden. You can learn there. And if you have a chance to go out with a naturalist, this actually is Julian Vincent taking some people out, do so. You know, there's all kinds of local opportunities for that, and it might be kind of interesting for you to go with this in mind. Okay, so this is a big week of discovery for you. This is the only video of the week. I hope you have a great time with it, and I will see you in the next video, which will be in week 7. Okay, we'll see you next week. Bye.